Hello aviators, Colonel Dwight with you to explain how to calculate density altitude using the FAA knowledge test chart as we see here on our screen. From our previous lesson, we know that the aircraft will not perform as well when the barometric pressure is lower than standard and or the temperature is higher than standard. And you recall a standard day is when the altimeter, when the pressure altitude is 29.92. The altimeter will read 29.92 at sea level when the temperature is 59 degrees Fahrenheit or 15 degrees centigrade. We must know how the aircraft will perform to make sure we can take off safely with the amount of runway available and to be able to fly over obstacles such as mountains. An airplane that can fly over a 12,000 foot mountain range on a cold day may not be able to fly over it on a hot day. We will now calculate the density altitude for the following condition. We have an altimeter setting of 30.35. Our runway temperature is 25 degrees Fahrenheit, and our airport elevation is 3,894 feet. Step 1 is to calculate the pressure altitude conversion factor using the chart on the right. We will find our altimeter setting first. 30.35 is between 30.3 and 30.4. So our conversion factor will be halfway between negative 348 and negative 440. So 30.30 is negative 348 feet, 30.40 is 440 feet. The difference is 92 feet. If we multiply this by 0.5, or 1/2, we come up with negative 46 feet. So we take 30.30 of negative 348 feet, we add another 0.50 to it, which was negative 46 feet, and we come up with a conversion factor of minus 394 feet. Step 2 is to apply this, the conversion factor, to our airport elevation. So our airport elevation, as you recall, was 3,894 feet. We add, or in this case subtract, because it's a negative number, our conversion factor of 394 feet, and we come up with a pressure altitude of 3,500 feet. Now be careful, because this may be one of the answers available on the test. But remember, we are looking for density altitude, not pressure altitude. Step 3. Now we find our temperature on the chart, 25 degrees Fahrenheit. Make sure you're using the correct scale. Sometimes our questions will, our problems will give us a Celsius temperature. The other times, like today, Fahrenheit. So what we want to do is find 25 degrees Fahrenheit. Let me click on this so we can see our mouse. It's going to be between 20 and 30, this line right here. And we're going to run this up to 3,500 feet pressure altitude, which will be right in the middle of 3,000 and 4,000 feet. Then we run it over to the left to the 2. This is on that line right there. And so our approximate density altitude in thousands of feet would be 2,000 feet. So even though our airport elevation is 3,894 feet above sea level, the airplane will perform as if it were only 2,000 feet above sea level. And that makes sense, doesn't it? Our pressure altitude is higher than standard, and our temperature is colder than standard. Let's try another problem. What is the effect of a temperature increase from 30 degrees to 50 degrees Fahrenheit on the density altitude if the pressure altitude remains at 3,000 feet MSL? We don't have to find a conversion factor for this problem. We are dealing with a constant pressure altitude of 3,000 feet. We only need to adjust for temperature. So we find 30 degrees Fahrenheit on our temperature scale. We run this up to 3,000 feet pressure altitude, and then we run it over to our density altitude. And we come up with approximately 1,650 feet. Next, we find 50 degrees on our scale. We run that up again to 3,000 feet. and then run over to the left to our density altitude of approximately 2,950 feet. So if we take 2,950 and we subtract 1,650, we come up with 900 feet. Aviators, please work through the other problems in this section. If you have any questions at all, need any help on the math, please give me a ring. Fly safe.